When supplying electrical service to multiple modular office trailers, it's essential to accurately estimate the electrical load to ensure safe and reliable operation. This involves considering the typical office equipment present in each trailer and applying a diversity factor to account for non-simultaneous usage. Several resources are available to help determine the power consumption of common office equipment. Energy Star provides information and tools related to energy-efficient products. The ASHRAE Handbook, specifically the HVAC Applications volume, may contain relevant data on electrical loads for office equipment. Energy Star also offers an office equipment power calculator to estimate energy consumption. To determine the total connected load, you need to identify the typical equipment present in each trailer. Common items include PC, printers, fax machines, coffee makers, microwaves, and water coolers. Obtain the power consumption in kilowatts for each piece of equipment. Let's consider an example where each modular office trailer contains the following equipment. Firstly, one PC at 0.15 kilowatts. Secondly, one printer at 0.5 kilowatts. Thirdly, one fax machine at 0.5 kilowatts. Fourthly, one coffee maker at 1 kilowatt. Fifthly, one microwave at 1 kilowatt. And sixthly, one water cooler at 0.2 kilowatts. The total connected load per trailer is the sum of the individual loads. In this case, 0.15 kilowatts plus 0.5 kilowatts plus 0.5 kilowatts plus 1 kilowatt plus 1 kilowatt plus 0.2 kilowatts equals 2.45 kilowatts per trailer. To determine the total connected load for all 7 trailers, multiply the load per trailer by the number of trailers. So, 7 units multiplied by 2.45 kilowatts equals 17.15 kilowatts. In small commercial buildings with multiple units, a diversity factor is applied to account for the fact that not all equipment will be operating simultaneously. A common diversity factor for this type of application is 0.65. This means that the connected load is reduced by 35%. To apply the diversity factor, multiply the total connected load by the diversity factor. In this case, 17.15 kilowatts multiplied by 0.65 equals 11.1475 kilowatts. Now, determine the feeder amperage. Assuming a 120 volt supply, divide the total load in kilowatts by the voltage. So, 11.1475 kilowatts slash 120 volts equals 92.89,583,333,333,333 amps. Therefore, the feeder to the 7 modular office trailers should be sized for a minimum of 92.89,583,333,333,333 amps. It's important to consult the National Electrical Code and local electrical codes for specific requirements on conductor sizing, overcurrent protection, and other installation details. The NEC provides tables and guidelines for determining the appropriate conductor size based on the calculated load and other factors such as ambient temperature and conductor insulation type. Overcurrent protection devices, such as circuit breakers or fuses, must be sized to protect the conductors from overload and short circuits. The NEC specifies the maximum allowable overcurrent protection for various conductor sizes. In addition to the general lighting and receptacle loads, consider any specialized equipment with significant power requirements, such as large copies or servers. These loads should be added to the total connected load before applying the diversity factor. It's also important to consider future expansion or changes in equipment. If there is a possibility of adding more equipment in the future, it's prudent to size the feeder and service accordingly to avoid the need for costly upgrades later. When calculating voltage drop, ensure that the voltage at the trailers remains within acceptable limits under full load conditions. Excessive voltage drop can cause equipment malfunction and reduce efficiency. The NEC provides guidelines for allowable voltage drop in branch circuits and feeders. Remember that these calculations are based on estimations and typical values. It's always best to consult with a qualified electrical engineer to perform a detailed load analysis and ensure that the electrical system is properly designed and installed to meet the specific needs of the modular office trailers. An electrical engineer can take into account all relevant factors, such as the specific equipment being used, the occupancy patterns, and the local environmental conditions to provide an accurate and reliable design. They can also ensure compliance with all applicable codes and standards. Furthermore, a licensed electrician should perform the actual installation to ensure that the work is done safely and correctly. Improper electrical installations can create hazards such as electrical shock and fire. The electrician will also be able to verify the calculations and make any necessary adjustments based on the actual site conditions. In summary, estimating the electrical load for modular office trailers requires careful consideration of the typical office equipment, the application of a diversity factor, and adherence to the National Electrical Code and local electrical codes. Consulting with a qualified electrical engineer and using a licensed electrician for the installation are essential to ensure a safe and reliable electrical system. Accurate load calculations, proper conductor sizing, and appropriate overcurrent protection are crucial for the safe and efficient operation of the electrical system in the modular office trailers. Don't underestimate the importance of proper grounding and bonding to minimize the risk of electrical shock and ensure the reliable operation of sensitive electronic equipment. A well-designed and properly installed electrical system will provide a safe and productive working environment for the occupants of the modular office trailers.